Hi, my name is Tarun, and this is my lab 4 for physics. So, the introduction. The goal of this lab was to study how a spring mass system moves when the mass swings in an arc motion. So, the tracker software was used to record and measure the object's position over time, and then the glow script model was used to model and graph the object's motion and energy, and the goal was to see if the system follows the energy principle. And the final result that I wanted to achieve was that the total energy stayed constant at zero, showing that the system follows the energy principle. So there were a few fundamental principles that we need to know for this lab, and the first one's Newton's second law, which says that the change in an object's momentum is directly related to the net force acting on it. And then the second is the energy principle, which states that a system's change in energy equals the total work done by its surroundings plus any thermal energy exchange. And other equations, which are update formulas derived from Newton's second law. So this was the tracker software, which had the video of the experiment, and the graphs on the right depict the x and y direction of the spring mass system's motion. And some of the initial values that we needed for this experiment were that the mass of, the mass was 0.402 kilograms, and the length of the spring was zero point 0.7 meters, and the initial position that the spring mass system started in was negative 0.122 in the x direction, negative 0.675 in the y direction, and 0 in the z direction. And the initial velocity was 0 as didn't have any velocity when it was starting. Okay, so we also needed some initial conditions that we needed to find. And the first thing we had to find was the period. Basically, the period is how much time it takes for one cycle to complete. So I just took the average of the first three cycles in order to get my period. I then calculated for the spring stiffness using the period that I calculated before. And then I also calculated for the relaxed length of the spring as well. So now on to the coding. So the first part was just the initial values that I had to set, the mass of the ball or like the mass, and then the initial position and the initial velocities, and then also g, and then the spring constant, and then the relaxed length of the spring. All right. So in this portion of the code, we calculate the system's energy. It first finds the spring's length, direction, and stretch from its rest position. Then it computes the three energy types: kinetic energy from the ball's motion, gravitational potential energy from its height, and the spring potential energy from how much the spring is actually stretched. And then finally, it adds all of them together for the total energy of the system, which should remain constant throughout the motion. And then this part of the code models the motion of the entire system using Newton's second law and the energy principle. So first, it defines the initial kinetic, gravitational, and spring potential energies. Then I calculate the gravitational and spring forces to find the net force acting on the mass. And using that net force, the code updates the mass's velocity and position over time. And then finally, I recalculate the energy changes in each step to show that while kinetic and potential energies fluctuate, the total energy of the system does stay constant. So this is the difference between the observed versus the computational. And you can see that in the beginning, the computational and the observed models overlap each other, but as time goes on, they start to diverge in both the x and y direction. And this is due to the influences of outside forces at work on the system, which are not part of the system, and doing work on the system. So forces such as drag. And that was one of the key errors. And then the second error was that the small inaccuracies in selecting the center of mass in the tracker software could also lead to measurement errors. So I could have not selected the center of mass accurately each time. So was the energy principle satisfied? Yes, the energy principle was confirmed because no external forces acted on the isolated system. The total energy change remains zero. Although the system contained different forms of energy, the graph indicates that the overall energy stays constant throughout. And then the comparison comparing the oscillation periods. So the oscillation in the x direction, I calculated it to be 6.01 Newton over meters, and then in the y direction, I calculated it to be 6.681. And I could see that the varying the direction of motion causes slight changes in the oscillation period, and which in turn could impact the calculated spring constant and the resulting graphs. Thank you.